Hello, these are my border collies, and they're keeping me company while I teach my lesson today. My niece loves the border collies, so I made her this bracelet, and encoded into this bracelet are their names. So for today's lesson, I'm going to challenge you. Try to figure out how I coded their names into this bracelet, and I'll show you how.
I used binary code to make my bracelet. Binary is like a very simple language that computers use to store lots and lots of information. We'll be using this binary decoder key from code.org. You can find a copy of it in the Google Classroom.
Binary code uses symbols to represent information. Just like we use letters of the alphabet to represent different sounds and combinations of sounds and words, and we use numerals to represent numbers, binary code shows information in symbols. But binary is simpler than our alphabet or our number system because binary only uses two numbers, the number 0 and the number 1.
Each letter in our alphabet is represented by 8 digits, either zeros or ones, in a specific sequence. Here's the sequence for the letter A. Each digit, either a 0 or a 1, is called a bit of information. A bit is the smallest piece of information. 8 bits together make 1 byte. See all these zeros and ones? Now that's a lot of code. Our computers and personal devices store literally billions of bytes of information. That's billions of letters and numbers. We're not computers, so we don't just have to use zeros and one to show something in binary code. In fact, we could use anything. Our sheet shows zeros as black boxes and ones as white boxes. I thought just for fun, I'd use things I could find around my house to write in binary code. See if you can decode my messages, and maybe even write a few of your own.
Can you decode my message? I'll give you a hint. It's a word. I spread it out to make it easier for me to make and for you to decode, but for a computer, these wouldn't be buttons. A computer wouldn't be able to decode the buttons. They would each be zeros or ones. So each black or white square would either be a 0 or 1, and a computer also doesn't need all these spaces to understand this. So let me just show you what it would look like if they were zeros and ones for a computer to be able to read it. Just barely fit in there. So there's my line of code. It means the exact same thing it meant before, just with no spaces. No buttons or beads in your house? No problem.
How about some old freezer burnt vegetables? This seems like a good use of them to me.
Peas, the black boxes, and my corn, the white boxes. And let's see if I can write a little code for you. Can you read it? Let's take a closer look. Peas and corn code. See if you can crack it.
I'd love to teach you a little bit more about how binary actually works on a computer or personal device. But if you've already had enough information for today, skip to the end of the video and try to decode my bracelet. Have you ever looked inside a computer? If so, you've seen something like this. This is a microprocessor. Microprocessors have switches on them, which either allow electricity to flow through the circuit or do not allow electricity to flow through. Binary code shows us whether each circuit is open or closed. Let me explain a little bit more.
So I made a little key for myself in my science notebook so that I could follow along. So I've written my initial D and I've written it out in binary code. Each black square means a 0 to a computer. Each white square means a 1 to a computer. Now those also match whether a switch on the computer is open, which stops the electricity from flowing, or closed, in which case the electricity can flow through that little switch. So I like to think of it this way. Black is open, which means that the electricity cannot flow, so it's dark. White is closed, which means that the electricity can flow, so there's light, just like if we turned on a light switch. So all of these squares represent either a 0 or a 1, and that's how a computer would understand it. So I'm going to translate my squares into binary code so that a computer would be able to read my code. There's a D in binary. It's easy.
So now you have all the information you need to read my bracelet. Can you use your decoding sheet to tell the names of my dogs? I'd love to hear from you. I'd also love to see something that you've written in binary code. You can use the template that I put in the Google Classroom to make your own binary bracelet with your initial on it, just using paper and pencil. Or write something for me to decode. I hope you've enjoyed our lesson, and I'll see you next time.